Hello everyone. So I'm Apurva Arora and my topic is modulation. Now, before telling you what is modulation, firstly let me tell you that these are the content. We will tell you about what is modulation, need for modulation, problems without modulation, problems solved with modulation, and references and conclusion. So before telling what is modulation, let me tell you about what is communication. So we know that there is a point and there's a B point, and you want to transfer any information like a message or a voice signal or anything, then it is either transmitted wirelessly or wired, right? So supposedly I will tell you about modulation, but before let us take an example of a boy who wants to throw a paper to a far away distance. So suppose it throws the paper, it cannot go far away, it will go around 1 meter or something, it wouldn't go far away. Suppose we want to throw it far, then we will wrap the paper around a stone and then we will throw, then it will go to a larger distance. So the same will happen to this. We'll relate this example to our modulation. Now, this signal which you see on the screen is the message signal which we want to send to a faraway distance. This is like a paper, it wouldn't go far away. The message signal does not go far away. Now we want to send it to a faraway distance. How would we do that? So for that we will need a high frequency signal which will carry this message signal. Now that signal is called as carrier signal. This is called as carrier signal of high frequency. Now, this baseband signal is actually combined in the carrier signal so that it can go to a faraway distance. So modulation, what is modulation? Modulation is the process where one of these properties of carrier signal like amplitude, frequency or phase is changed according to the baseband signal. Based on which property is changed, there are different types of modulation. But we won't focus on the different types of modulation, we'll see its applications. Now, why there is a need of modulation? We'll see that. So basically we can see that there is a radio station here and the message signal is transmitted to the tower and the tower is sending those signals to the radio. Now these signals are actually transmitted because of the carrier signal, as it is as the message signal and the carrier signal are combined, and this signal can go to a faraway distance. We can see that like this is the message signal, this is the high frequency carrier signal. Now it is combined, now has the amplitude of message signal. We can see that, right? Now why modulation is used. So first of all we'll see what is the need of modulation, right? So we would need the modulation because we want to reduce the antenna size which we are using to transmit the signal to the radio station. Now, what is the problem with the antenna size? No, the length of the antenna should be 1 by 4 wavelength of the message signal, right? Now, if we suppose take an example, that is the wavelength, that is the frequency is 10 kilohertz, we say. Yes, the 10 kilohertz is the frequency of the message signal. Now, if you want calculate lambda, lambda becomes 3 into 10 raised to power 8 upon 10 raised to power 4, because that becomes 30,000 meter. Now if you want to calculate the length of the antenna, length becomes lambda by 4, which is 7,500 meter, which is practically impossible. Have we seen an antenna of 7,500 meter? It's impossible, right? We cannot make it. Now why is it that why is it that large? Because the frequency is less. When we take the frequency of the message signal, when we take the message signal and the carrier signal, when we combine those, we can see that the frequency actually increases. Frequency of the combined signal is increased, thereby it will reduce the length of the antenna. We can see that here, that to reduce the antenna size, that is the frequency is 10 megahertz supposedly now, and if we calculate it, the length becomes 7.5 meter. We can see that lambda is equals to c by f. C is nothing but 3 into 10 raised to power 8 upon 10 into 10 raised to power 7, वो ऊपर गया तो 3 into 10 raised to power 1, which is 30. Now 30 by 4 is nothing but 7.5 meter. Okay. Now, the second reason why we need modulation is to reduce the interference. Now, what is interference? When three or more people are talking simultaneously to a fourth person, will it understand it clearly? Of course not. It will actually not understand anything clearly, right? So, this is interference, and we want to reduce it. We can see it in the example of radio station 2. See, this is a message signal that is in the radio station which is transferring to a tower, and there is also a tower nearby where this girl is sitting and the radio is there. Now, if the frequency of both the signals that are transmitted from the tower is same, then the radio will fetch both the signals because of interference, because of which the interference will occur. Now we want to reduce this. How will we reduce this? When we combine a message signal and a carrier signal, the frequency changes. Now the tower signal will, though both the tower signals will be different because of change of frequency. So there is a difference of frequency because of which there wouldn't be any interference. So we have solved this both the problems. So that's why this modulation is needed in communication system. And this modulated signal is actually demodulated. What is demodulation now? Actually, we can see that there is a transmission of this signal, right? So this is a mixed signal which has carrier signal with it, but we want only the message signal which was the original signal, right? So we have to decode it. So this is nothing but demodulation. That is, the modulated signal is actually demodulated using the demodulator. Yeah, so it will be separated out into the message signal and the carrier signal. So that's it. We have taken references from many sources, and thank you for listening to me.